Okay. So I found one, but this is taken over as a new writing tool. Pencils and crayons crayons are not accurate enough. I mean, they're good for writing big notes on things like don't throw this away. And pencils are too light. So these are pretty good. But also for writing on the actual fiberglass, these will work. So they're great for that, right? The big fat is even better. But remember the first day I had you do the signs and I had a bunch of those I tapped out and ransacked the place. I couldn't find them. Yeah, they came back, but that was before he's rearranging things in the middle. Did you guys work on that room? Oh, the Saturday class?
Yeah.
Well, it's great. I mean, you're making progress. It's not done, so I can't find anything. I don't mind looking. I looked. What was I looking for? Oh, a stapler. And I said, Tim, I called him up last Friday. I said, do you know where these are? He said they're in a cabinet inside one storage. Which I didn't even know there were cabinets in it. So I went.
Yeah,
did find them. Yeah. So anyway, it'll all get straightened out. The other thing is for cutting it, obviously these are good. You guys know about the difference between these kind of T-rock knives. I can talk about that. There's these, but in order to change the blade, you gotta unscrew it.
Yep.
And that's a little pain in the ass. So these are really the best. That's the kind that just, and then you can take the blade out and then keep the extra blades in there. I mean, now there's variations. This is the first one for a long time that had all that. And it's worth paying the money because it doesn't slow you down. So how many of you use flat pencils? And do you guys ever sharpen them with the sharpeners? Or do you just no? How much was that? They actually work pretty good. I never had them when I was here, but I like. I like the, you can tell personality by the way they sharpen the pencil. Totally. I go around, I look like, I find out a lot about this. But see, this has a little hook in it for cutting thread. I mean, twine and stuff, string. But if you're cutting insulation, this catches in there. So I just put a piece of electric tape on the one that I cut insulation, then you don't get smooth on them. That's one thing. You can try out to prepare them. We're gonna measure. I mean, I was gonna go set up some walls. There's a wall back there last week, and then I come today and he's got it all set up for the insulation. So we'll put it up and we'll take it down, or he can take it down when he does the electrical. But it's perfect, right at right at the right height, staple in, so you don't have to do anything. I was gonna have big walls, but let's talk about cutting. We'll take one measurement and cut it. So these are called bat for you newcomers, okay? BHAT, it's not bat like creatures that live in the night. Well, BATT, I guess it is. BATT is an Indian word. BATT. These are bats because they're cut the length. You buy and cut the length. Let's see how long they are. Anybody?
8 feet.
8 feet exactly, you think?
So
a wall, 8 foot wall
no,
has
a little bit,
three plates in
a
it.
little bit less.
That's 4.5 minus 8 feet. So 96 minus 4.5, 90.
91.5.
91.5. And I see 91.5.
Yep.
Okay. So yeah, so remember that, the top of the wall where the sheetrock goes is 8 feet, but you also have the plates. This won't go where the plates come. So you got 3 plates. Actually, they're having bigger plates now, so I don't know how these will work with the thicker bottom plates, but
You just cut the bottom off a little bit.
yeah, or just you don't want them stuffed very much, so you can stuff them a bit, but if it's starting to wrinkle it, that's not good. That'll create convection thing. So at that point, you do need to cut it a little bit. But you can muscle it in a little bit. Now, see these tabs here I was talking about? We used to put them in like this. In the wall, here's a stud, and then just staple it to the wall. But now this goes over the wall. So the front of this goes right through the sheetrock. So that's important. The best way to cut these, and let me measure something so I don't waste it. So somebody take that camera and make sure it's
Yep, already done.
in the right place. So that's like 30 inches short. Do one. So if you cut like this, the paper's gonna get in the way. It's gonna, you know, what's the word? Crinkle up on your brush. It's really a pain in the ass. And yet that's the best surface to mark, but you have to give that up. Because otherwise you just destroy that. And you need that, paper on it. So you have to measure from this side. And I usually just take a. Now, if you guys are experienced at this and you have a better way, you see a better way than I'm doing, let me know. That's the way we're doing this now, okay? So anyway, we'll measure 30. See, this thing will mark right on it. Nothing wouldn't do that, right? A pen, I mean, I started using pens after a while before. These were always out, but no one figured out, hey, let's put a Sharpie. And then you can, if you can't draw a right angle by vision, most experienced carpenters sort of know what it is. You can get a framing square and do it. But anyway, you just put that on there, and you could, you know, you can mark that or not, because you're gonna cut it right away anyway. So bring it back over, probably. There it is. And then put this down, not on your customer's nice oak floor. But I usually carry a little piece of plywood, but I didn't do it today because we have these utility tables. But put something under there, so, or you know, so you're not gonna do it. And then just push that down. Cut right through it. Might take a few you should be able to do one every cut. Yeah, that's gonna use the working. And then come on over a little closer. Well, I can do it here, I guess. I'm moving. They're all gonna be. They're identical, so we're good. This is so great that Tim did before. So these are made to fit a standard. I came out here with tape measure, made sure they were standard layout. So see, they fit. They fit pretty well, right?
Mm-hmm. Never actually used the tab. Good to know. If I had known that a month ago, dude.
I think that's a little bit low. That's where you see that on that picture. So that's probably passable. We'll pull it up just a little. You know, these may not be square for all reasons, right?
Slam it on.
They're square.
I'm not saying anything. Just saying maybe.
Brian, that yours?
Okay, so that's
Oh,
pretty
you
good.
guys.
Now, when you put your next one on, it's gonna cover that, right? So you're not gonna really be able to see where the stud is. So you might come back with this thing. Or have your drywall do it, drywall do it. Pretend the other one's already there. It's gonna cover this up. I just want to show you. So you can just put a line like that in the center of this. Pretend the other one's underneath that. I could have put the other one on and done it over that, but I didn't waste that. And then the drywall just comes, you know, doesn't make it there. Okay, any questions so far? Now, there's one other thing. When you're at the beginning of the wall, what's different between this bay and this bay? In terms of width.
Oh, that one's shorter.
This one's shorter, and then you'll often have a short bay at the end, right?
Yeah.
Where it runs out. Let's take the one because it's really visible.
Yeah, like this one. Mine, yeah.
So that's gonna be, so now we're gonna worry about the inside measurement. Before it was standard, so we didn't even cut it the length. But this one is gonna be different, so it's like 10 3/4. is what the actual fiberglass has to be. And then we need a flap on each side, right? Here's the trick. So let's say that was 30. So we'll cut another there. So see, maybe this will show how to see how it cuts it in once or twice. So no use. Then we said 11 inches with the inside.
10 3/4.
10 3/4, yeah. Okay, so we'll leave one side as it is, right? And then we'll go in 11 3/4 from this side. 10 3/4. I mean. Now this one, you might want to mark it because of the longer cut, right? Yeah. I did bring out a longer stick you could use. Now, if you cut this straight through, you're gonna cut the paper same width as this, and you're not gonna have a lift for it, right? So you gotta cut it not all the way through. So you have to be careful. So let's see if I can be careful. It could take a couple cuts anyway, so make one. You know, don't have to worry about the first two cuts. And then you can even pull this back.
Make sure you're wearing eye protection too when you do this,
Yeah.
if you're doing overhead stuff, because getting that in your eyes is,
Yeah.
it stings and it burns, it's.
So, you know, the thing that I would be carrying with me,
An hour tower.
well, I don't know.
Remember last semester when I came in, just freaking.
I don't know if Jake is here, but a pair of scissors. The fast way to cut in a straight line. But we just need this width, right, the tab, so it doesn't even have to be that accurate. Just come 1.5 inches. Okay, and that should work. Let's try it. So probably even could have been even bigger. That's close enough, okay. You'll see how that still has that flat for nailing. So that's why you need to be careful, not to cut all the way through. I cut it like most of the way and I peel all back, so it's just a little bit of this, and I could sort of see where it was, so I could cut that last one really not too deep. Okay, so the new people who haven't done this before, why don't you measure the height of something and the width? If it's a middle one, it's gonna be standard. If you want to start with the standard, they only cut the length and it will automatically fit that middle one. But if you want to do a shortened one, the one on the left's like 3/4 shorter and the one on the right's whatever. The length of the wall ends up. Want to do that? Has everybody done it?
I've already done it.
So you know
Do that again.
have done it before and know it. Why don't you look at people doing it?
Yeah.
And then we know they've done it.
Like what?
I've done that.
Yeah.
I've probably done.
Yeah.
did a lot of conversation, he told me. Kind of like, not like, very like general. Not one thing, like, days ago, more so like. Oh, yeah. All right, nail every couple inches on the perimeter and then every time it feels like doing like that.
So here's another idea that Manny had that he does. So come on over if you're interested in tips.
Yeah, move it.
So for short bay, he puts the
Yeah.
he puts the fiberglass into the right side,
Yeah,
and he
well,
just
it's like,
takes that flap and just
like,
pushes it back.
put it in, but it's-
And then on this side,
Yeah.
this bay is just 3/4. This paper's just 3/4 too big. He separates the paper and pushes it back. And then whatever's sticking out on the fiberglass, he just cuts that along the edge. So you could also do that, Manny, by holding it back when it's cut to the floor. Like I did, I was cutting it, you could just fold it back like this. And just measure where
Or you
you
can have
cut it.
spectator
So
hold.
either way, those are both better on.
So it'll pan back and forth.
Yeah, so this feels the way, okay, you can push it out of the way. You can on the wall, you can also do it on the floor. and then
Work it up and people cut it.
Yeah, good point.
Let's say.
You guys, if you do this, not only is it the main thing, but if you work with them on the budget, you almost always pick up just. The supervisors, you know, the way they're doing, when I get insulation, I feel like, yeah.
Yeah.
Yeah. So
I
they'll,
just get shit caught in the.
professional, I mean,
twine.
insulators. that
Never
often-
thought about,
yeah, because
like,
when you cut the
I
sign,
don't know why.
but that, you do right in place. You don't have to measure it.
No.
That's the exact. So it's easier to cut, it's easier to measure the cut.
Three things that I've done the most.
Yes, sorry, thank you.
Sweet
Sweet
thing.
thing.
Sweet thing, JD. I've done a lot of digging.
Probably Windows.
It's.
Oh, yeah.
Those over.
Yeah.
The other way.
Yeah. You can do it. Try it with, one.
Demos down.
Oh, yeah. That's another tape.
Maybe they're new, but I'm doing like the past like. Whatever. Exactly.
No.
So,
In the
it's
wall.
been pretty common.
No, it doesn't do it all.
Started out in trouble.
Yeah.
Is
It's
that when someone wants to buy new? You wouldn't expect it.
not an error.
But once you finish the meeting, you can say, hey, I noticed some things about your house. Nonetheless, you did a good job of the meeting. And then you go on.
I did a lot of utility, but like when I didn't know.
Yeah.
My boss, like, really good.
One right.
Yeah, it's a fiberglass, yeah.
That's a dumbass. No, I like David and Sean because like actually what they said.
No, I noticed that.
He throws new guys in like fire and he takes responsibility for that stuff.
Yeah.
My dad throws me in the fire, but it's only been like for 3 years. That's reasonable to be, it's a door right there.
Closer it is, the less, I just. Reflecting left there.
No, I didn't start it here. I started out,
Want to break it.
I was like little, we were remodeling our house. I see, and I was just like throwing sheets up and I was like.
You were also.
Yeah.
And he knows.
You know what?
You can't, I really can't think back that far. But like I said, I haven't done like a lot of one.
Yeah. It's been a while.
For me, it's all wet. I can't remember like the first job or any.
Yeah. Yeah.
Blended.
Like, that's what's called.
You know, the one thing I was good at that, you tear down a small thing on the wall, and see how it's, you know, it's done properly. Yeah, we do that. I would definitely check.
I mean, he's not.
If it was all.
Not his finger up.
Yeah, a couple, but.
I used to grab a.
Patrick said he doesn't measure the backside of it, because I always use the backside. Back. No, yeah. Because you like a lesson on the back.
And I do it on the floor.
Yeah.
On the floor. My arm.
And they look like
Yeah, they look like it's doing that. I feel like honestly, boy, like, well, when you're more when you're sweating, you're the way it all opens up.
as soon as everything goes down here.
You don't want to bear it on.
Something it's instantly.
Except like flooding. I think it's about where it's bad.
Well,
But
now
I would
what's
say
not.
definitely needs to be.
But if it was.
You're just like over it. Step on the two.
I have
Not a lot of it's not.
What is that place?
You know.
No, we built. Yeah, because we own the property.
But the paper does slow it down.
Oh, so that's where.
That's why you gotta. Also, the reason they have, it's still not, it's not.
Framed up.
It won't fall, because you gotta put a bunch of.
No, no, no.
On the street, I'll do that. That's probably.
Right next to the where roast.
Oh, yeah, yeah.
Like a shop or like a factory.
It's like a factory. So you just find out that, and then they sell.
We made it so all has this big window and you can see the process that it's being made.
Oh, right. So I should like house casual.
No, I don't live there.
Oh, yeah, we're gonna talk about it. Hey, everybody, how you doing?
It's the commercial.
We got a couple things to talk about. See this right here? So.
Grade two. That's grade two right there.
Yeah.
It's a good wall, isn't it?
I mean, look, even mine's got some, I mean, I wasn't trying because I was trying to show you, but that, one of those would be okay. That one may be okay, but more than that, they'd say, oh, come on, that's not good enough.
Yeah.
But it's, that's how you find out, they really gotta be.
Did you stuff something in there, like a piece of foam? Caulking?
No,
Caulking, yeah? I don't know.
no, they don't really like that.
Okay.
Somebody was saying, you know, some fiberglass comes without backing,
Trash.
and could it be used in a wall? And not really, because the stapling keeps it from falling. So if in a standard bay, it's gonna be a pretty good friction fit. You almost have to muscle it in there a little bit.
Yeah.
And that keeps it from falling. But if you're cutting one for a short bay and you cut it too small and you just put it in and leave it, that's gonna over time fall. Gravity's gonna pull it down, then you're gonna have a big gap. So they usually want it. And also, if you put the barrier on the outside of the wall, further in, it acts as a slight air barrier. It's not a perfect one because it's just, you know, it's just covered. The air can come in between the flats, but it still for the middle part acts as an air barrier. And that will keep air that maybe has moisture from going out of the wall fast. And it may, you know, be a problem with condensing in the wall. Probably in an area like this, it wouldn't make any difference. But in a real cold region, you'd never see that. They used to allow that, but now because they're really uptight about it, touching all sides forever. The only way you can do that is to really staple it or spray it in. So I want to show you guys that because it's part of the code now, you know, like Manny was, he was at a job and was it you, Manny, was just telling me about it? Yeah, and they covered the drywall before the inspector inspected the insulation and he made him tear the drywall down. That's not good. And I said, if I was the inspector, I would have torn one small section of wall, looked at the job they did, and if it was a really good professional job, I'd say, okay, it's probably fine. He said they tore down all the walls. If you tore down one wall and it's a crappy job, you tell them to tear down all the walls, because you'd assume they did the same job everywhere. But, so they can do that. I don't know if they're all told to do that, if it's up, tear it down, because they have to see it, but that's how, but see, it seems picky to us, but we're talking about combating global warming. And every bit of insulating and keeping the hot air from going out means we use less heat from a coal or oil driven energy plant, which is adding fossil fuel. So this state's really serious about it. That piece I showed you, I don't know if it was California, I think it may be nationwide now that they're doing that with insulation. A lot of times California is way ahead of everyone else because we're really trying to, do our share of fighting global warming, but that I think is just becoming standard. I mean, 5 years ago I teach this and people had never heard of that. And they'd say, well, what's this? But now it's actually in the code. So there was one, oh yeah, the other thing, and I forgot to do it, I was gonna drill holes. The wall I usually do it was taken somewhere, I don't know where that went. But it has electrical wires in it. And electrical wires are typically put in the middle of the wall because they don't want sheetrock screws to do it. So they don't put it to the front. So if it's in the middle or toward one side, doesn't matter. People will take insulation and push it against the wire or put all of it. If the wire is close to the front, they'll put all of it behind the wire. What does that do? If you put it behind, either way, behind or above, what does that do?
Compresses it.
It compresses it, but also it makes a convection area, right? Because you're, it's to one side. So you really need to take this stuff, man, peel it. The great thing about this is you can just peel it in half like that. And then stuff half of it in front of the wire and half behind it. Or a third, you can do it exactly the proportion of where the wire is. That's really important. If you want this to touch drywall, no, this to touch sheathing, this to touch drywall, this to touch studs, this to touch plate, everywhere, 6-point touch. Keep that in your mind.
You see what I'm saying?
So yeah, so the wires and the pipes, you want to split it, go around it. I think you got the drift of this, huh? Was it fun? Drywall is actually pretty fun. It's kind of mindless, so it's easy. It's not sweat it. It's a little hard.
I don't know.
Sometimes Rodney used to have he's a friend of the guy who runs the main Santa Barbara insulation company. He has a shop down on Garden, but I don't like the guy personally, so I never invited him. But they mostly do spray foam, so he can tell you everything about spray foam. And he might be able to tell you this stuff. I don't know. I'm sure if they do fiberglass bats, then his whole crew would do this. But yeah, I never like the guys. I don't have Rodney likes all those guys. But I was in the contractors, contractor association, Santa Barbara. I was on the board for a number of years, but they wanted someone from the school. And so I was on it, and Rodney was on it because he was a good contractor in town. You know Rodney, right? But so this guy was on it. A lot of guys were on it. I got to know them. They weren't my type of person. So yeah. So let's go in. Let's go in and look at some insulate, some film, some videos, and then we'll cut something short. We won't see the whole thing. Tape, not here. Let me have the sheetrock knives with tape on them.
Wait.
And those two.
I got it with mud.
No, you're not. I don't think they're the same thing, because spackle you use for.
Yeah, so this-
You use spackle to cover
all
up
these
nail
are
holes,
plastic.
painters, you know,
Anything else got glass?
rotting an entire wall.
When I say I'm gonna smash it,
Just put them somewhere on my desk or on the table.
everyone's.
It's very similar.
Yeah,
Well, I mean, it's technically the same process, you're covering up all of the holes.
Holes,
marks, you know. And it might be the same
No one's
material.
ever corrected me, so I don't know.
Hey, if no one's ever corrected you, you're right, right?
That's what I think. But again, I could be like, oh, I'm gonna spackle, and everyone's like, that kid's a dumbass. Let him hear you. So I don't know. I don't know if it's lost. They don't back. Yeah. Almost really. Oh, yeah. I hope so. Is it still recording?
Really not done.
Yeah, you wanna see? No, it's all the camera angle, but it's all right.
Camera adds 10 pounds, right?
Yeah, it does. Somewhere. I don't know where. Is it still recording?
Yeah, it's still recording.
You just need to.
I saw your car.
I messed
yeah.
up my room. So I stopped.
Buddy,
It was pissed.
look, are you Jewish?
I knew someone was
You
gonna.
gotta be careful, you gotta be careful when you ask that question, because it's like, how did you know?
How did you know? Dog gonna need. What do you think? Tell your girlfriend I said I'm sorry. Did you not like? Did she not like Jimmy Shepherd?
Oh, it's the right one. Okay.
Yeah, there's a camera.
Is that camera on?
Yes.
Yes. It's all recording, it's all okay right now.
This gets the podium and the whiteboard.
It's gonna be all.
Right here.
The audio is gonna be.
I'm drawing a circle. Spiral circle.
Okay, somebody hit one of the lights.
Or.
Windows.
Essentially, R value is a measure of how well a barrier, typically insulation, can resist the conductive flow of heat.
So. Let me gloss it real quick. So R value, R stands for resistance. I don't know what U stands for. U is an engineering term, the inverse. And I think they started with U and then they just took the inverse of that and made a scale for R value. But she's gonna explain what it involves, but you don't have to know it. I'm not gonna touch on it. I just want you to see what goes into how they design that scale for R value. That actually has a real meaning.
Here, the area of the sample and how long the measurement took place, divided by how much heat was lost through the sample.
So that's the temperature difference on the inside and the outside of the wall. They take the difference and then they measure by the area. So you could do a square foot if you wanted to and find out what the R value of that square foot is. By the time, I don't know what the time is, she probably explains it. And then the heat loss. They have a machine that here, this engineer has a machine that does it. It'll show you. So I don't know. I think now they just pop everything in this machine and it measures the R value kind of instantly. Here's a the difference in temperature, the area, the time, so per hour, and then the BTU. So British thermal unit is a measurement of heat. And so you don't want to get into that.
Is the area of the wall or of the room?
No, it's whatever you wanna, the R value, that, like, if you have an R13 insulation, it's probably a square foot measurement. So you could do a whole wall and the area would be bigger.
Okay.
But I think for those common values, I think they must take a square foot. Because that's what would make sense, right? Because walls are different heights and width and stuff, but you wouldn't do it. If you wanted to compare it, you do square foot.
Square meter per watt. To convert R value into RSI with
Yeah,
a higher R value is a better insulator than a material with a lower R value. The American Society for Testing and Materials, or ASTM, created a C518 standard test method for steady state thermal transmission properties by means
Lady built this machine. It's
like
gonna
a
deal
printer.
with all those parameters.
STM, SSTTP.
of the heat flow meter apparatus. This test is 3
So then they-
Celsius with no emission and conduction through
Well,
air.
this is really.
Lastly, the effect
Well,
method.
it is
Heat is
interesting to me.
transferred by conduction when fibers are
So
separated by air.
this is a
Heat
cross
is
section
transferred
of,
by radiation
this is a cross section of a piece of fiberglass. And you have, let's see what it say.
and conduction through air. Lastly, the effect of any
So you
convective
have
loops
conduction
within the
inside
insulation are also
Some little
tested.
air pockets.
Now let's discuss all the problems with this test. R values are determined in artificial lab environments, which are nothing like the real world. When do we ever have 75-degree Fahrenheit weather with no air movement and no rain? The test
All
prioritizes
the time.
resistance to conductive flow of heat. Also, since
Okay.
most homes are not completely sealed off, there are holes in the exterior siding that allow air to be sucked inside. Air movement within the walls, in attics, and around insulation completely changes the R value. This is more evident in flexible insulation like fiberglass, mineral wool, sheet wool, etc., because they have gaps where air can move. Spray foam in between studs and continuous rigid insulation can stop air infiltration, so their R values are similar to the lab results. I'll link a study in the description which showed that a home with R12 foam insulated walls used half as much energy as an identical home with R20 fiber insulated walls. Just because two products have the same R value doesn't mean that they perform the same. Another issue is that the R value test does not start until the materials have reached steady states. Fiberglass insulation reaches steady state within a few hours.
Yeah, and foam takes a while to dry. So that's an interesting thing. So one of the, and we probably won't get to it too much tonight, but one of the, so they've started calling these new energy efficient houses different names. Passive house, we talked about, and we'll sort of focus on that because it's kind of the easiest to understand. They have one net zero energy home. They have a zero carbon home. The zero carbon, because it's carbon that's causing all the problems, so you want to do products or things. Yeah, you want to do products or things that don't get rid of a lot of carbon, right? Like fossil fuels get rid of a lot of carbon. So they do a thing called embodied energy. Have you ever heard that term? So it means how much embodied means how much was put into the body of that material, how much energy it took to make it. So some materials are really, like concrete has a lot of embodied energy because it has high temperatures that it cooks at, and so different things take different energy to make. And if we're trying to get rid of carbon, we want really low embedded energy, embodied energy. So he was just saying that spray foam has much less embodied energy in the process of making than fiberglass. So in that sense, it's better. It's an air barrier, vapor barrier, and it's higher R value. So the only negative thing about it is that it's toxic as hell when it's wet. So the people who put it on are very vulnerable to this toxic thing. So when you see these guys come out, they have hazmat suits on. I mean, they are dressed to the nines, you know, because that spray. And you also can't spray that where the spray is going to be blown to the neighbors. So if you're doing it outside or an open area, you have to make sure that you stop that from going. I mean, the inspectors are really, just like the insulation, they're really crazy about that. You can get fined a lot because it's toxic, you know. You get on the next lawn, the dog and the babies, you know, crawl around on it. So they're really uptight that you have the setup perfect, and of course, the professional companies do it right because that's their business. So, but once it dries, it's completely inert and non-toxic. However, if a fire comes and it burns, it's toxic again, but then everything else is toxic too in a fire. We can't, this society doesn't seem to be able to make things that can ride out fires safely. And, you know, let's just hope there isn't a fire, and there isn't always a fire. So in many ways, that spray foam is really a good product if it's done safely. And it's a little more expensive, but it's it does so many things at once, so it's really good. Whether it's appropriate for Santa Barbara with our mild climate is another question. I'm not sure it is. I think fiberglass bats, and if you want to make a little bit of an air barrier, you can just put sheetrock, which we'll talk about later. You put a bead of copper where the sheetrock hits the plate, where a lot of air can come up and keep the air from going out there. And that works pretty well for this kind of climate. You don't need to go crazy with it. If you're up in Montana, then you want to go the full length. You want spray foam and everything's got to be perfect. We'll talk about, I told you about that machine that gets the cracks by spraying in the filler. It's in the smoke, in the gas that it puts out, and the house is pressurized, so it wants to push out, so it goes, so the stuff that's in the gas, this machine makes this gas flow, this stuff that blocks holes, it goes to where the hole is, and it gets caught on the way out and plugs the hole. So you don't even have to know where the holes are, this machine will do it for you. We'll show you a film of that later when we start talk about filling the holes. That's the first we want to talk about how heat moves, and we want to talk about
How much of a gap would cover
how much what?
of a gap, like what, like any kind of. hole?
Yeah, any kind of, yeah. They, in fact, in one of these films, they purposely made a big hole like that,
Uh-huh.
and it kind of goes in stages, but eventually it's all done.
Oh, wow.
It's pretty impressive.
Yeah.
And they just created them like, 5 years ago. I mean, usually when you hear about it, like, 5 years old. So they're just gonna improve it. You know, it's fairly new, but I'm totally sold on it because I've lived in Maine for 10 years. I built in Maine. It's very cold there, right? The state of Maine. And so we have it. So we put plastic vapor barriers on the inside everywhere, and you have to be very meticulous. You have to caulk them and staple them where they join. You have to make sure you get everywhere. I mean, it's labor intensive, but you don't want that cold air, moist air to get into the wall at a warmness air, because it'll condense in there, and so they have to do that. So for here, I don't know, so many things. I'm telling you guys what's good for here and what's good for colder, because you may end up in colder climates. You know, you may get a really great job in Texas where it's hot, or Florida where it's hot, or you may get a really great job in Chicago. And that's a whole different thing. It's colder, they use a lot of these techniques. So I just wanted to I'll tell you what we don't do here so much.
So when you talk about that plastic, to prevent the moisture from going in, you put that behind the shipping or after
You put it on the inside.
in the inside?
So you put this, you have the wall, you fill it with insulation, then you put plastic,
Oh, okay.
tape with all the stud,
Okay.
then you put your drywall in that.
But wouldn't
They have
that
snow there.
keep the moisture?
Like whole season.
No, because the moisture,
There's a lot of break-
in a
no,
cold
whole
climate,
season fires.
the moisture is coming from inside, your shower, your cooking, your body, your breath of warm moisture.
Oh, okay.
And that's going through the wall, going out, because it, hot seeks cold, right? That's one of the thermodynamic laws. So your heat will always go to the outside because it's colder out there. So it's going that way, but you want to slow it down. No, nothing stops the air from going to the wall, but if you slow it down a lot, then it won't be a problem.
You'll have enough time to dry on.
Have enough time to dry out. So you want to, that plastic is really, and it's controversial. Because I teach this, I've researched it over the years, and there's such a battle about what the best thing to do is. Some people say never use plastic vapor barriers, and it's really a hot controversy in building. But everybody, when I was building in Maine, which was in the 80s, 1980s, everybody would, and from there to Canada was using plastic vapor barriers. So, but the more science they learn, they find out, well, there may be a better way. So it's pretty interesting, but I think we're still doing that. But then this new foam came along, that's a vapor barrier. Why not, right? You don't need all that labor intensive stuff, you just spray it in, it also acts as insulation. You need that kind of insulation in places like Maine or Chicago or up north.
Do you think, like a climate like San Francisco Bay Area where it's not like so cold?
That's
it's got-
borderline.
Right,
That's
it doesn't
borderline.
snow, but it does. get
Right,
rainy and
that's
chilly.
borderline. I would do a lot more than I do here, but I wouldn't do what I would do in Montana or
Mhm.
Maine. And there's, when you live up there, you live up there, but when you live up there, the contractors will tell you what is
Right,
done. And then, so here's the thing for your house, especially if you live in other climates. When you're gonna do something and spend money, make sure you research it on YouTube. Right? And say, what kind of insulation is used in San Francisco? And they'll talk about it and they'll say, well, it's in this climate zone, we recommend this. Then when you talk to a contractor and he wants to go way overboard, they say, well, do we really need that here? And if he gives you a decent answer, then he's okay, but you gotta be unfortunately leery of contractors that are out for their money a lot of times. And, so the more you know, the better you're prepared. So even if you're not gonna build, you're gonna work on your own house in the future, it's nice to either know this stuff or know where to find it. So YouTube's got, it's really blossomed over the last 5 years. It's got tons of stuff on it that's pretty good. So anyway, that was, if you ever wanted to know, we don't need to look at more of that. Let me do just, no, let me see. This thing is weird. At home, my computer, I've got all the saved things on the left side. So I can just get them in here. They're all on the right, and they're all in weird shape. So that's a problem with having different kind of computers and platforms. So here's one on double wall, which I won't think we'll look at tonight. It's kind of a new thing on double wall. I was surprised, because they don't always. There's SIP panels, you've heard of those? Where they put foam, rigid foam in between OSB, oriented strand board
Mhm.
on one side and maybe sometimes sheetrock on the other side, sometimes plywood also on the inside. And then they put big panels and the factory can make 12-foot long panels. And there's no thermal bridge because there's no studs in it. There's no studs, the whole single floor and maybe double floor, depending on how it's made. No studs in the wall, just the foam and the plywood and OSB holds it up. It's a pretty cool thing. And they, you send them we'll talk about it more in detail later, but you send them the floor plan, your plans. And they find out where all the electrical outlets are and where the circuits have to go. And in the factory, they make holes in the foam. So the electrician can run and the plumber can run the pipes through. And then they deliver the whole thing to you. It's really amazing. And if they make a mistake or you change your mind, they have these little tools. They're like a thin, rigid piece with a hot thing that melts the foam, and you can make your own chases in it if you need to. So it's not, once it's done, it's not the end of the world. So I show in the green building, I show a lot more variety of types of homes and construction, but this is more of a nuts and bolts class for you guys that are working in this. So I don't want to show anything that's not. Here's that aerial barrier. Can't wait to show you that. Pretty cool. Rock wool, that's what that's called. Now, rock wool was a generic name for that stuff, and I think a company, and Jacob may be right, I don't know what the name is. It might be rock wool, might be the name of the company now. But they've taken that generic name and made it their, their name. So, but I want to soundproof part of my house, and I throw the sheetrock off and I put it in. It's really good for that, for the inside. I don't need insulation.
Have you ever done blow-in insulation?
What's that?
Have you ever done blow-in insulation?
I've never done it, no. Either the loose stuff or
then you don't tear down the sheet rock, just make little holes and blow it in there.
Yeah, no, I've never done that. I should have, but I don't know how, I mean, I don't live in a house that needs it, but I should have seen it somewhere, because it's, you know, they put, actually, usually they put two holes, they put one in the middle and one toward the top. And then, I mean, it's just a technique, you know, it's not that complicated, but I've never even seen it done. You know, here, if people buy an old house and doesn't have insulation, they just live with that because the climate's so good, right? And if they're building a new house, then they can do whatever they need to do for insulation. So it's not real common here in this town. I think for those reasons. They did have this old house thing, a really good showing of the different types of insulation. And then these passive houses, Matt Risinger has done a couple of passive houses, all gun law, we've got a couple of things. We'll look at those later.
That's it.
Man, train,
Lost. But it's true. I live by that.
okay. I don't know where the virtual house went, I'll get it later, but what is that, quarter after 8?
Yep.
Okay,
Yeah.
let's make 8:30 our total. Ooh, did I say that out loud?
9:30.
Yeah, 9:30. Yeah, let's just do advanced framing real quick for the rest of the time. Because this, the passive home, we're gonna be talking about net zero and super efficient homes, the rest of, all throughout the course. And, you know, okay, so passive house has 5 principles. One is super insulation, which we're talking about now. One is air sealing, which we're talking about now, and we're gonna actually have a unit on that. One is windows, which we're gonna have a unit on. So we can split that up into all the times we're gonna cover those things. So I just had, like Tim, make sure I had enough stuff. But you know, what's funny is Jacob hit it so right on the spot. You guys are pretty astute. I divide up the class into units, and I don't want to mix some of the units, you know, or do too much. I just want to kind of focus on that. And you never know how long it's going to take. Some people may have a ton of questions about it. So once I'm done with that unit and there's no questions, I'm ready to go. So sometimes I do have short classes, and I teach unit wise and not just time wise. So that's the difference. But Tim wants, he hasn't said it, but I know he would like me to teach close to what he does. So I'm trying, I'm giving it my best shot. Even though I have such sympathy for you guys. Poor soul, tired, hungry. Okay. So advanced framing, we looked at corners, right? That's, I think, the most important. And I'll show you the clip next week. The little shoebox clip. Not a lot of people are doing it. They use a clip, it's against everybody's mode of doing things. But it really, I try to push it because I think it's a real, for the future, it's a great way to get more insulation and use less wood. I mean, who could be against that? The same thing with the channel. You know what a channel is? So in framing, it's where an interior wall meets an outside wall. We don't have any here because this is, you know, a stupid place, but so you got to insulate behind that where they meet, right? So let me draw what so here's the outside wall. Here's the inside wall. Here's a stud on the end. This has, say, a stud there and a stud there. So in the old days, we used to make a channel which consisted of one stud, same size as the wall. It's 2x4 interior walls are often 2x4. And then we tack a this is kind of a weird drawing because I didn't do it the right proportion, but you tack another couple of studs on the side of that, and then you have nailing for your sheetrock. But now you've got this channel, and the weirdest thing is that insulation traditionally, conventionally, starts after the sheathing's on, because you don't want it to get wet, right? And then it goes against the sheathing. So if you put the sheathing on, then you can't get to this little place in there. So you have to remember to do that before the sheathing. So that requires a process that's not ongoing any other way to come in and do that. So that's an issue, is doing that. If I did it this way, I'd do it before the sheathing, I'd probably put rigid insulation in, just stuff, series of rigid blocks, because they can get wet or rain. But then you also use 2 extra pieces of wood. And that adds up, because there's a lot of intersections like that in the house. And also what? No. So what they did, the next step was, okay, we'll just put a block here, bigger block. Nail to this, and then there'll be nailing for the drywall here. Well, that's okay, except you get that same triangle with the insulation. Right? So you've still got those conduits, convection conduits. But that turned out not to be good. Then they said, well, let's use a 1x. A little 1x happens to be here. Well, that's a little better, but you still have the conduit. So the truth is, well, they did all kinds of things. They did ladders, so they have things go from here to here, all the way up like a step, and then this could be nailed all the way, which is horrible because then you've got the insulation going in between those. So everybody thought, well, that's a great idea. But then someone said, well, you know, we got the corners, we're doing that drywall clip, why don't we just do it here? So same thing, you have the clip, I think it must nail in this way. Like, I'll bring them, I can't remember. So you nail it to here, so you know, nothing from the way when you nail it. And then when you put the sheetrock on, you put the first sheet against the clip. Yeah, here. And then you put the next sheet, ram it against that, so it's up tight against the clip. You can screw it there. And screw it there. And then you don't need anything. And look at that beautiful place for insulation. So this is called a channel, because that was like a channel. An old name. So you got corners and channels. Another way to save wood, this doesn't involve insulation, but yeah.
So then is the interior wall only attached at the bottom and top plates?
It's attached at the plates. Yes,
And that's secure enough?
yes.
Okay.
Yeah, that's what they found out. Now, all these techniques have been tested by the building department. They wouldn't allow it unless they were comfortable. So yeah, you got it. That's it. It's just there. And of course, the sheetrock makes walls stronger too. Now, the thing I was gonna say next was getting rid of the double top plate using just one top plate. That was another idea to save wood. And insulation, because you got more insulation with that. But if you do that, then the second top plate was to lock this. Well, that's another reason. They have 2 top plates. Second top plate would go along and lock that into place, so it would have that plus the toenail at the bottom. But when they did away with that second interlocking top plate, then now you have to put a strap across it. Metal strap. It doesn't have any thickness, so it doesn't get in the way, but it costs money. Especially now, metal straps are more expensive. So, you know, that cuts back at some of the savings, but that's what they demand. Also, if you do a second floor, the framing, the studs have to be on top of each other. Because the reason for the double top plate was to distribute the weight for uneven spacing of frames above and below. And but to do that, you know, walls aren't just the same windows, top and bottom, and they vary. There's all kinds of variation. To get that to line up, it's a lot of work. And it's hard for the crews to learn to do that. And the time they waste learning that and figuring it out, I don't think it's worth it. So that's one of the things I think don't even bother with that. It's too insane to do it. And then if there's some reason you can't do it, you've got to figure out all this stuff to compensate. So that's the one advanced framing I don't like, the corners, channels. 2x6 walls are considered advanced framing because they can space 2 feet, allow more insulation, less thermal bridging, but in the northern climates, they've used 2x6 for years, so I don't consider it a new thing, but it does save wood and it does add more insulation, so they've incorporated an advanced framing. Anybody know any of the other techniques? On this page, the pictures probably didn't come out real great on your, it's the last page. The last page shows the the second to last page shows the corner and the ways they did it before. All the history of it, kind of. They don't actually show one with drywall clips, but they show a channel with drywall clips. I'll go figure. Anyway, I'll bring some minutes. Oh yeah, the other thing was the header. The header over doors and windows. Originally, it was, if you had 2x4 wall, it was a 4 by something, 4x6, 4x8, because it was the same thickness as the wall. But to get a 4x8, it's a much bigger tree than 2x4. And we're in our old growth forest, it was slim. So they said, well, what can we do? And then the engineers realized that you could sandwich stuff together, didn't have to be solid. So you can make up a 4 by 2 2x4s, that makes 3. And then you put an inch, say an inch of insulation. Right? If it's 2x6, what do you have? 1.5, 1.5, 3, 1.5, 4.5. 5.5, if you have an inch, so you can put an inch piece of insulation. So that's good because you get in, usually the headers are this huge thermal bridge. It's just a giant piece of wood that the heat goes right through. So if you can break it up with some insulation, that's good. The advanced framing found out that the windows and doors on the non-bearing side, like if you have this is from above, you have a gable roof, that's a triangle like that. The rafters are all coming down here, so these are your bearing walls. So these end walls, they're hardly holding up anything. So you can use minimal headers. If you have a door or window on either of these sides, you don't need to have the same size. You can have like a 2x4 or a couple of 2x4s because there's no weight. It's just mainly to tack, the coverings on both sides. So that was a big thing too, to get rid of that. So we may cover advanced framing more because I don't want to slip picks you guys do 1 minute of it. And then so next week. What's our oh, I think I got everybody. I asked if what'd you call him?
Xander.
I guess he's not. I dropped them anyway because they say if you're unsure, drop them, you can reinstate them.
Yeah.
But he's missed so much. I just didn't have time I forgot and didn't have time to send him an email, but I'll maybe I'll do it now.
We'll tell them on Saturday.
If he really wanted and needed the class, I'd let him in, I think. Maybe too late, we'll see. I'll email him tomorrow. And I think I got everyone else. So next week, let's look at this, your Bible here. Diagnosing shell air. We'll talk about that. And then we'll show a video on the blower door ahead of time, so you know what that's like. And then we'll do a blower door test on this door here. And so you guys can do that. And actually, if some of you want to like really know how to do it, not just see it, you can do it. And if nobody volunteers, I'll just make some of you do it. It's pretty easy. But you probably won't do a blower door yourself because it's part of a different kind of. It's part of an audit. But you may end up in an audit company, like. You know, you may end up doing audit stuff as well as construction, so then you really wanna do the blower door. Plus. For you to, since everything's gonna be blower door from here on out. When you get the data, you'll have to know what that means, right? And how, what house you're doing compared to the other house, so you'll learn at least that much. And if you take this like BPI or any of these tests, they will, blower door. Performance is part of the class, part of the test. And I'll tell you this toward the end of the class, but if any of you do any of those trainings. I'll talk to Tim. When I was chair, I could just say it, but now I have to say, I'll ask Tim. Good, I'll show you guys, I'll take some time off of a class or on the weekend. If you're getting ready to take one of these tests and you need to be more familiar with the doors, then I'll take the time to work with you. I've never had anybody take me up on it, but it's an open thing. By the end of the class, you may get an idea if it's something you want to learn on. But read, there's stuff on blower doors, just kind of context and orientation in your book. It's pages 23 to 28. Make sure you read that. Because the more you have context when you come to class, it'll make more sense. The book's got a lot more stuff on blower door. Some of it we'll look at later, but before you do the door test, you don't even know so much. That's probably enough there, 5 pages. No, we'll do the test. It's kind of fun. Okay. No more questions? Want to go home? Okay. Am I forgetting anything? No. All right. Good problem. Okay.
Stop recording.
Julio, you were, no. Probably,
Oh, yeah.
you were at.